So we start with the concept e raised to x fx plus f dash of x dx gives us e raised to x fx plus c. Okay. First we will prove the result. So I start with I is equal to integration e raised to x fx plus f dash of x dx. We open the brackets. So it is e raised to fx dx plus integration e raised to x f dash of x dx. Now we keep this on hold and apply integration by parts here. This becomes my u, this becomes v. So fx integration e raised to x dx minus integration of integration e raised to x dx into derivative of fx, that becomes f dash of x dx, and this part as it is. Integration e raised to x is e raised to x itself, so minus integration of, again this is integration e raised to x into f dash of x dx plus integration fx f dash of x dx. Now if we observe, and obviously a plus c, if we observe, this is negative, positive, same expression, we strike it off. So we are left with e raised to x fx plus c. This is how we obtain this result. Now we are going to apply this for solving a few problems. So let us start. The first question, it says I is equal to integration e raised to x sin x plus cos x dx. As can be observed, cos x is the derivative of sin x. So we take fx is equal to sin x, which means f dash of x is cos x. Therefore, I becomes integration e raised to x fx plus f dash of x dx. Using the above result, we get e raised to x fx plus c. We resubstitute fx, it is e raised to x sin x plus c. Okay. Next, now we are solving questions which are from the 7.6 exercise of the NCERT textbook. The second question says integration e raised to x 1 plus sin x over 1 plus cos x dx. Here we are going to use the concept of trigonometry. 1 plus cos x is 2 cos squared x by 2. Sin x is 2 sin x by 2 cos x by 2. Therefore, I is e raised to x 1 plus 2 sin x by 2 cos x by 2, and here in place of 1 plus cos x we write 2 cos squared x by 2 dx. Next we split the whole thing. This becomes e raised to x 1 over 2 cos squared x by 2, and here 2 sin x by 2 cos x by 2 divided by cos squared x by 2 dx. As can be observed, we can strike this off. One cosine can be cancelled with this, so I end up getting e raised to x 1 over cos squared x by 2 becomes sec squared x by 2 divided by 2 plus. Now here I am left with tan x by 2. I'll rearrange the whole thing. This is e raised to x tan x by 2 plus sec squared x by 2. Now if you check, this is the derivative of this. Derivative of tan x by 2 is sec squared x by 2, and by applying the chain rule we get the derivative of this half, that is 2. So we can safely write this as tan x by 2 plus the derivative of tan x by 2. This gives us the answer. This is applying this rule, e raised to x tan x by 2 plus c. Okay, let us try one more question on the same rule. This says, question, I is equal to integration e raised to x over 1 plus x the whole square dx. So what I'm going to do here is split this as adding and subtracting 1. First I add and subtract, and in the next step I will split this. So this becomes 1 plus x over 1 plus x the whole square minus 1 over 1 plus x the whole square. We may strike this off, so we get e raised to x 1 over 1 plus x minus 1 over 1 plus x the whole square dx. Now again, if we write this as fx, f dash of x will be, we can just write this as raised to minus 1. So now f dash of x is minus 1 into 1 plus x raised to minus 2, which becomes, in other words, I have I is equal to integration e raised to x 1 upon 1 plus x minus plus the derivative of 1 upon 1 plus x. Applying this rule, the one here, we get the answer e raised to x into 1 over 1 plus x plus c. Okay? So this was how you apply this particular formula to solving problems.